Hello everybody and welcome to Sirius. I'm the lead developer, Thomas Ballas. So what is Sirius? Well, the name itself is the phonetic pronunciation of the original project name's acronym. It started out as SRS, which stood for the Steganographic Relay System. If it's not immediately obvious to you what that is, don't worry, I'll explain it in just a moment. What we wanted out of our project was this. We want to be able to send very dangerous messages from hostile environments to the world at large. What we created was a handset application. A new user will start out by creating some accounts with us. In our prototype, we usually logged in with Imager, and so we'll do that here. Our user Ballas Thomas will authenticate our application using a portal provided by Imager itself. Once they hit allow, they've given us the permission to post on their behalf. But say our user doesn't like Imager, or they just want to connect their Facebook account for reasons their own. They can do that as well. Similarly, they'll grant us permissions to post images on their behalf to their Facebook wall. So user logs in, grants us these permissions, and then they can begin using Sirius as it's actually meant to function. Starts out with new message. Very similar to, say, using Twitter, they'll get a text box. And in this case, they'll write something along the lines of, the local government is treating activists as terrorists. From Saudi Arabia, per se, this could get the user imprisoned and or executed. Once the user's finished, they'll hit send, and this will pull up the Android camera. Using this camera, they'll take a photo of something completely innocuous, in this case, a lamp. Hitting the shutter button, the application will begin processing the image and then send it off to a website. In this case, it's sent off to Imager. So they finish up there, and if we come back to our server's Twitter account, we can reload the page. We'll see that their message just appeared. But if they uploaded that photo to Imager, how did the message get to Twitter? Well, the answer is at Imager. What we're doing here is we're using Imager as the 21st century equivalent of a dead drop location. And the dead drop itself is the photo. It contains the secret message that we want to send. But where's the message? Well, we really have to look closely at that photo. We have to know that there's something more to it than the photo. So let's look closely. Let's look at the pixels. To a computer, a pixel looks like this. It's some string of data. What we have here is the hexadecimal representation. To a computer, it's ones and zeros. Looks a little bit easier like this, but to us, it's colors. Now, the difference between whether it's a color or it's data doesn't really mean much, except to the computer it means a lot. So if we pull out this string, we convert it to binary, we'll see these ones and zeros. If I change the very last one in the bottom right corner to a 0, it fundamentally changes the data to the computer. That final 3 became a 2, but to us the change is completely imperceptible. So if we jump back to the photo, we'll see that there's no difference in the upper left corner. So we could take a couple pixels, and we'll change that final 1 to a 0. And so as you see here, a bunch of our 3s just became 2s. If I were to take each of those 1s and 0s from the bottom right corner and put them together, it would be very similar to using the first letter of every word in a message to spell out a secret message, like many of us did as kids in school before we passed notes. Using a very similar method, this is called least significant bit steganography. And in using it, we've been able to send our users very dangerous message from a hostile environment to the public at large. If you're interested in this project and would like more information, please feel free to view our website or to contact me at the email provided. Thanks for watching.